Get the worksheet used in this lesson, as well as hundreds of others, at Mathcation.com. This video is about how to do scientific notation. You can get the worksheet used in this video for free by clicking on the link in the description below. In order to show you how to do scientific notation, you have to first know the main parts of scientific notation. There are two main parts of scientific notation. It is the base being multiplied times a power of 10. So for example, you could have something like 7.7 times 10 to the 8th power. The base always has to be in between 1 and 10, and the power of 10 is always a base of 10 being multiplied times an exponent. In order to show you how to do scientific notation, you're going to be taking really large numbers, like say 7 million, and rewriting it into the form of scientific notation. Or really small numbers, like say 0.00005, and rewriting it into scientific notation. Now you will notice a few things about our rewritten numbers into scientific notation. Our base here is in between 1 and 10. It did not matter if the number was really large, like 7 million, or if it was really small, like 0.00005. The base remains in between 1 and 10. In order to get the exponent, you have to count how many times you move the decimal to get to a point where the base will be in between 1 and 10. For this number, we moved 6 times, so our exponent was 6. For this number, we moved it 5 times, so our exponent was 5. Now you will notice that this 6 is positive and this 5 is negative. The easiest way to remember if an exponent will be positive or negative is that to get a positive exponent, our starting number is larger than 1, and then to get a negative exponent, your starting number is a decimal, or less than 1. So if you look, this number here, 0.00005, is less than 1. It's a decimal, and our exponent ends up being negative. This number, 7 million, is much larger than 1, so our exponent is positive. The first problem we're going to use to show you how to do scientific notation is number 1. So our directions say to convert the following numbers into scientific notation. We have to convert 500 into scientific notation. So we know our decimal starts here. We have to move the decimal to a spot that will create a base that is in between 1 and 10. In this case, if we move the decimal 2 times, our base will become 5. If you moved it one more time, it would become 0.5. That is not in between 1 and 10, so we don't want to use that. So we'll stop right here at 5. Then we move the decimal 2 times, so we know that the exponent on the power of 10 will be 2. And this time it's positive because we started with a number greater than 1. So our solution for 500 in scientific notation is 5 times 10 to the 2nd power. The next problem we're going to use to show you how to do scientific notation is number 3. Number 3 gives us 0.007. The first thing you have to do is we have to take our decimal and we have to move it to a spot that will create a base in between 1 and 10. So if we move it to here, it will create a base in between 1 and 10. So now we have to figure out what our exponent is going to be. Well, if you look, we move the decimal 1, 2, 3 times. So our exponent will be 3 because we moved it 3 times. But we started as a decimal, which is less than 1. So 0.007 is less than 1. And because this is a decimal, that means our exponent must be negative. So our final answer is 7 times 10 to the negative 3rd. The last problem I'm going to show you how to do scientific notation is number 6. We are given 0.000045. So the first thing we must do is we must move the decimal to a spot that will create a base in between 1 and 10. In this case, we move it to in between 4 and 5 because 4.5 is in between 1 and 10. So this is our base, and we have to include both the 4 and the 5 because they are both a part of the original number. So when you write the base, you have to write 4.5 because it's both a part of the decimal. Then we're going to write our second part of our scientific notation, which is times a power of 10. And then we're going to count how many times we moved the decimal. So we moved it 1, 2, 3, 4, 5, 6 times. So our exponent is 6, but our number starts as a decimal, which means that the exponent must be negative because we started with a decimal. And 4.5 times 10 to the negative 6 is going to be the solution for this. If you found this video helpful, make sure you drop a like, subscribe to our channel, or check out our website for more premium math content. Thanks for watching.